Hi, my name is Louis Storms. I just finished building a 7.5-foot tall cedar fence with dual swing gates spanning 12 feet 4 inches. I think it looks sharp when gates blend in seamlessly with a fence, so I wanted my fence and gates to be as seamless as possible, without hiding the fact that the fence has gates. Other than the gate hinges and trim notches, the fence segment is uniform. There are no partial pickets, no noticeable gaps around or between the gates. The fence and gates have the same top and bottom trim, which is in alignment and level across the segment. This fence and gate is the first I've ever built, so I watched numerous fence and gate related YouTube videos before I started to learn from the experience of others. I benefited from the contributions of others, and this video is my attempt to pay that forward. My old fence posts were treated, but they still managed to rot. The rot was always at ground level, a few inches above and below the top of their concrete bases. The fence was 14 years old, and if not for the rotted posts, it was otherwise in decent shape. Given how much work it is to replace fence posts, I wanted to make my new posts last much longer than the old ones. I treated the below ground segments of the posts with roof coating. I took care not to coat the bottom of the posts to allow for a way for moisture to escape. Each post hole has a few inches of gravel in the bottom to allow for drainage. I'd also like to point out that I put 3-inch deck screws into the posts where they are anchored in cement as an added source of stability. Posts can shrink within their concrete footings, and my hope is that the screws will help prevent movement. I also applied about 6 inches of heavy-bodied asphalt to each post at ground level, 3 inches above ground and 3 inches below. I may not win any style awards, but I'm definitely style conscious. If the bottoms of the posts are going to be coated in asphalt, at a minimum, it shouldn't take anything away from the look of the fence. I think I achieved this by going up only 3 inches from the ground on each post, and also by ensuring that the asphalt lines are clean by using painter's tape during application. I'll almost certainly have moved before these posts fail, but I always try to build things as though they'll be mine forever. I wanted my fence to be level across the top, but the ground closest to my house is higher than the ground at the farthest post. I also wanted to build the tallest fence allowed by code, which in my case is 8 feet. The top rail and cap collectively contribute 3 inches to the fence height, so to have a level 8-foot fence, my tallest post at my lowest elevation needed to be 7 foot 9 inches. To figure out the above ground post heights, I put stakes in the ground with a tight level string between them, and then measured the distance from the string to the ground at each post location. For example, posts 3 and 4 in this picture will each be 5 inches shorter than the tallest post, because the ground at those locations is 5 inches higher than the ground at the tallest post. Recall that I wanted the gates to be seamless with the fence, with no noticeable gaps around or between them. To achieve this, I targeted no more than a 1/16 inch gap between each gate and its post, and no more than a 3/16 inch gap between the gates. I always try to solve for the highest risk parts of projects before I do much else, and so that's what I did on this one. I decided that I could order tasks in a way that would be forgiving of any minor mistakes I might make in earlier steps. I would build one gate first, then set the gate posts with backer rails, and then build the second gate to the exact dimensions of the space remaining. Based on my amateur skill set, I assumed that the second gate would be some flavor of trapezoid, but only minimally and undetectable to the naked eye. Risk number 2 had to do with hinge placement. I did a basic mock-up of my fence based on a design I had on paper, and from the mock-up it became clear that I needed to decide on my hinges before building the gates. If I had built my gate first without regard to hinge dimensions, I risked a scenario like this in which the hinges I later picked out would interfere with a capboard, trim, or kickboard. So I bought the hinges before I built the gate. So instead of building this gate, I knew to build one like this and put the hinges here instead of there. In my mind, another risk was hinge stability. Any unexpected play in the hinge action could jeopardize how well the gates fit together. I addressed this risk by building a mock-up with the actual hinges. Fortunately, there was no play in the hinge action, but in the process of building the mock-up, the hinge screws split the pickets. I'd probably have pre-drilled the pickets on the final fence without this reminder, but it was a good reminder nonetheless. The last risk was uncertainty about gate post movement, given how heavy the gates would be with all the trim and the use of 2x6 horizontal members. I figured that if the gate post flexed under the weight of its gate, even after tying the post into its neighbor post and adding pickets, I could use a cable and turnbuckle on the backside of the fence to stabilize it. After solving for all of the external risks to gate integrity and performance that I could think of, it was finally time to begin gate construction. One of the keys to preventing a gate from sagging under its own weight is to use lap joints. In my case, because my gate needs to support top and bottom trim, it ends up being called a cross lap joint. I didn't have a table saw when I built this gate, so I had to use a circular saw and a chisel to do all of those joints. I set the circular saw blade depth to exactly half of the depth of the gate frame cedar boards in preparation for the lap joint cuts. Then I used the circular saw to get as much of the meat out of the joints as possible before coming back through with a chisel. It is essential that the outside edges of both vertical members of the gate frame are square. It's unlikely that all of the gate frame lumber is perfectly dimensioned, and in my case the horizontal 2x6s were particularly non-conformant. As a consequence, I used a string in combination with a board I knew to be straight to square the vertical gate frame boards, and then I used a scribe to mark the horizontal and cross brace boards for cuts to fit within the exact space available. In my imagination, experienced carpenters that manage to watch this video will be scratching their heads at the long way I went about doing this. If you've got a shortcut that gets to the same place, leave me a comment. I always love to learn new tricks. The next thing I want to cover is the diagonal brace. I watched a lot of videos online about how this ought to work, and I didn't really find anything that I was satisfied with. So here's what I'm talking about. This part of the gate frame behaves like a crane. A diagonal brace is needed to resist the downward forces on the top horizontal member of the gate frame. In every online video I saw about gate frame construction, they had the diagonal brace connected to the bottom horizontal member of the gate frame. That seemed like it would put unnecessary stress on this lower lap joint. It made more sense to me to have the lower diagonal brace connected to the vertical member of the gate frame to avoid putting stress on the lower lap joint. However, screws and wood glue are all that secures the brace to the frame, and it made me uncomfortable to rely so heavily on the sheer strength of screws and wood glue. I finally settled on a hybrid approach in which most of the diagonal brace would sit on the vertical gate frame member, and a smaller portion would rest flush against the horizontal member to help resist shear forces on the screws and wood glue. This seemed to me to be the best compromise, and I used the same approach on both ends of the brace. Here's a tip I picked up from watching other videos, and it definitely saved me from making a mistake. When you're laying your pickets on the fence, start with a gate post and work your way away from the gate. This avoids the possibility that you'll have a partial picket on the gate post, which I think would look sloppy, but more importantly, it avoids having the gate post portion of the hinge resting on multiple pickets. I replaced the manufacturer-supplied hinge screws for the gate post with 2.5-inch hex screws. I also replaced the supplied gate frame hinge screws with hex bolts all the way through the pickets and gate frame. Note the 45-degree notches in the top trim that exists on the bottom as well so that the gate can open. Cables and turnbuckles were definitely needed to get the tight fit I was looking for. The hinges manage the 1/16 inch gaps on the ends, but that 3/16 in the middle between the two gates was a real challenge because of the flexibility of the posts. The gates were snug at the top, and if I went over to that upper right hand corner of that fence segment and pushed that post, I would get the gap that I was looking for between the gates. Once I added a cable and tightened the turnbuckle, I got the gap I was looking for. I also added a cable and turnbuckle to the other side, and with both cables in place, I could control the gap between the gates with precision. You can't drive through a neighborhood in Houston without passing by 30 or more wooden privacy fences and gates, and ever since I built mine, I pay close attention to every one of them. I'm sure they exist, but I have yet to come across a fence and gate that meets the standards I set for mine. This is clear evidence, beyond any doubt, that I just way overdid it. I hope this video was of value to you, and if so, please let me know. I'm always doing some DIY project or another, and if it turns out that my videos are helpful to other people, I'll post more. Thanks for watching.